Hey, it's Mr. Surbeck here. This is another episode of Science with Surbeck. Today we're going to be talking about is a very essential lab skill, and that is how to use some of the basic equipment that we use in chemistry and physics. So the first thing that I want to talk about is a graduated cylinder. Now, a graduated cylinder looks like this. I'm going to zoom the camera in, but a graduated cylinder will look like this. And so it has a lip at the top to pour liquids in, and then it has these very nice readings that we utilize to measure the volume of a certain liquid. Now you have to be careful and you have to know what type of graduated cylinder you are dealing with. So right here we have a 50 milliliter graduated cylinder, and if you look closely between each of these big lines, so for example here between lines, the big line 20 and 25, if you count really close, there is 1, 2, 3, 4 of these little lines in between the big ones. Now, if you remember, we went from 20 to 25, and so what that means is that each of these lines represents 1 milliliter. Now, on a different type of graduated cylinder, I have a 10 milliliter graduated cylinder, so it looks the same. The only difference is we have 10 milliliters of liquid that this is capped out, or the capacity of this is. And if you note, it's a little bit hard here. I'm going to turn off my light to see if I can't get a little bit better. Oh, there we go. You can see here, I know not well, but in between each of the big lines represent 1 milliliter, and in between each of the big lines there is a total of 4 little lines. Now, those represent 2/10 or 0.2 of a milliliter. So the whole point of this is to be careful of what you are measuring with and how to use it. And so how we use a graduated cylinder is what we're going to talk about next. So what I have in front of me is just a real simple sketch that I have done of my 50 milliliter graduated cylinder. So how we use this is really important. So let's say I pour in a liquid, and I'm going to represent that liquid with this blue Sharpie. And what happens when the liquid fully forms is that it comes and it looks like this. And you can see it has a curvature. Now that curvature is known as the meniscus, and that's just because of some of the properties of liquids, and that graduated cylinder is filled up to that meniscus. So now we have the opportunity to read how much volume or how much liquid is in our graduated cylinder. So the first thing that I want you to note is if we filled up a graduated cylinder up to this mark, we are between 40 milliliters and 45 milliliters. Each of these lines, if you can remember back, each of these little small black lines represents 2 milliliters. So if I went up to here, that's 41 milliliters. If I went to here, that's 42. And now you can see my curved line does not quite reach 43. And another important note here is even though that curved line, the meniscus, starts and it may touch 43, we read at the very bottom of the meniscus. So the very bottom of that curve that forms. So we know that our line, or the amount of liquid here, is between 42 and 43 milliliters. So what we can do to record how much volume is in this is we can write down 42. Now, as scientists, we want to go one step further, and we want to give our best estimate of what we think or where we think that meniscus is at, or how much liquid we can estimate. So we know it's at least 42 milliliters. We know also it is not 43 milliliters, and so we estimate this next digit. So I can tell, or I can estimate here, that this meniscus is right there close to the 42 line, but it sits just above it. So I'm going to say this is 42.2 milliliters. Again, that last digit after the point, or after the 42, is estimated. So what I need you to do when you measure things in science class is estimate one past what you know. And again, that last digit in a device like a graduated cylinder is estimated. So what I'm going to do now is I'm going to pause the video, and we're going to talk about another type of measurement device that we can use in science class. So the next type of measuring device that we have, or that we will utilize in science class, is a meter stick. Now in this meter stick, and I'm going to shift the camera over, in this meter stick, if I zoom in a little bit, I want you to note a couple of different things. One, there are a lot of lines on this meter stick. And so in each of these lines, we have some different things. So every large line that you see represented with a number, this one right here where my finger's at is 10, then you see 1, 2, 3, and so forth until 20. Every single line here represents a centimeter. Now, in between each of these centimeters, you see this small line that represents a millimeter. So we have a 10 millimeters in between each of these centimeters. Now again, before we get into actually measuring something, I want to go over and I want to talk about how exactly we would read some particular device or some particular object that we are trying to identify the length. So again, I have a mock sketch up here. I'm going to zoom out a little bit. I have a mock sketch of the meter stick that we just saw. So in this particular scenario, let's say we laid down an object, and let's just say it is this highlighter, and we laid it out, and we had this particular measurement. Now, in this measurement, if I can get the highlighter to hold still, in this measurement, we have a couple of different things. One, our highlighter goes to right here, and I'm going to draw it in a blue line. And so we can tell the highlighter is at least 10 centimeters. We add another centimeter, 11, 12, 13 centimeters is the length of our highlighter, but it's smaller than 14 centimeters. So when we would go to record the length of this object, we know it is at least 13 centimeters. So we can go ahead and write that down. And then just like we did for measuring a liquid, we put a decimal point to represent how far out this goes. Now, a decimal point right here represents 1 millimeter. However, we have a millimeter mark. So when we're using a meter stick, what we need to do is we need to put 2 decimal points when we're using centimeters. So we see here that it is at least 13, and this would be 13.0 right where my pin is. And right here, this would be my first millimeter, and so that would be 13.1. So our measurement here is between 13.0 and 13.1. And so I can see it's really close to this 13.1. I'm going to call that 13.08 centimeters. And that's how we would measure using a particular meter stick. Now, what I'm going to do, because I've gone over how to measure with a graduated cylinder, I showed you the practice one, and I've done the same thing for a meter stick. What I'm going to do is I'm going to pour a liquid into my 50 milliliter graduated cylinder. I'm going to have you write down what exactly the measurement is of that amount of liquid, and then I am going to do the same thing. I'm going to have a book measurement for you to measure with the meter stick. So give me a second here. Okay, so what I have for our measurement of liquid using a graduated cylinder is just some blue Gatorade. That's all this is. And I'm going to put it in that 50 milliliter graduated cylinder. So again, what I'm going to do here, I'm just going to pour a little bit of this blue Gatorade into our particular graduated cylinder. And so I'll bring it back over, and I know you can't see this very well, but you can see that there is some liquid in the graduated cylinder. So to measure this correctly, what you need to do is you need to get eye level with that meniscus. So what I'm going to try to do with the camera is I'm going to adjust it so that you are eye level with that particular meniscus. And I'm going to do my best to get as close and as zoomed in as I possibly can. Okay, so what you see here is this. You see that the liquid is above that 35 line, and then I'm going to leave it up to your interpretation of where this actually is. So if you're reading this closely, this is 35, and then this next line where my finger is, the little one, represents 36 milliliters. Again, you are at eye level or as close to eye level with this liquid as possible. And then right here, it's hard to see because it's a little bit bigger graduated cylinder, but that is the bottom of our meniscus. So remember 2 things when we record this particular amount of liquid. 1, we need to predict 1 decimal place and put the label ml for milliliters. So you know it's between 35 and this line. You need to predict 1 additional number. So go ahead, take a look. You may need to pause the video, take a look, write down on your lab sheet what exactly the value is for this amount of liquid. Okay, so again, if you need to see it again, rewind the video. What I'm going to do now is I'm going to use my ruler, and you are going to measure the length of an object that I have on the ruler. Okay, so what we're going to do to measure this particular book is use our meter stick. Now, one thing I failed to mention when I was going over how to utilize a meter stick is this. My meter stick is relatively old, and I'll try to zoom in here. And you can see that the ends here are starting to deteriorate. What that does is that prevents us from getting the most accurate measurement. So when you're utilizing a ruler or a meter stick, I never start flush with the end here because that prevents or that gives us error. So what I do when I'm trying to measure the width of this particular book is I take, and I'm going to have to shift my camera over. I take and I start out at 10 centimeters. So my 10 is like my 0 that I had at the end. The nice thing about this is that I know this lays flush with the particular item. It's not inaccurate is what I'm trying to say here. Now, the next thing is this. So we go from 10 to 20. That is a whole 10 centimeters. And then we have 11 centimeters, 12, 13, 14, 15. And then you can't quite see it here, and I'm going to zoom in a little bit. But it doesn't quite get to that 16th centimeter. So right now, we know that the width of this book is at least 15 centimeters, but it is not quite 16 centimeters. It ends right before here. And so what I want you to do, right here where my finger ends is the width of the book. So what I want you to do is I want you to write down the width of the book in centimeters. And remember, for this measurement, because we are using this particular meter stick, I need the answer with 2 decimal places. So you know it's going to be at least 15. What you need to do is predict 2 decimal places past 15 utilizing the measurement right there where my finger ends, because that is the end of the width of the book. So go ahead, take some time. Again, this is an estimation, so it doesn't have to be perfect, but it should be in the ballpark region of where this measurement is. It's at least 15, but not quite 16. I need you to make 2 decimal place prediction to have that accomplished. All right, so if you need a little bit more time, again, pause the video or rewind it. But what we're going to shift to now is our last device that is commonly used in this class, and that is using a digital scale. Okay, so up to this point, what we have done is we've done analog measurements, or we, or myself, have actually utilized that tool to measure whatever we're trying to accomplish. So with analog measurements, like the meter stick or like the graduated cylinder, you need that prediction of that one additional number that you are estimating. Now here with a digital scale, what I have here is the digital scale, and I just have the little clear top, and I push this on button here on the left hand side, and I get the scale to 0 out. And so what that is doing right now is that's saying, hey, even though this thing has a plastic top on it, it does not factor that into measuring the particular plastic top. So it's reading all at zeros. Now, with a digital device, that prediction of that one additional number that we did with the graduated cylinder and that was done with the meter stick is actually being done on the scale. So with this scale, this second decimal, there's a decimal right here, and then this second decimal place, that is actually a prediction by the scale. So it makes it really nice with digital scales or a digital instrument is that the prediction made by the scale is already done for us. That's how the device is set up. And now this is turned off on me, so I'll turn it back on. And now we'll go through actual measurement. So again, in chemistry or in physics or in any science class, you should never weigh something directly on the scale. So what you need to do is this. I put a beaker in my particular scale or on my particular scale, and it measured out to be 96.77. So you need to write that down where it says mass of empty beaker on your particular lab sheet. What you need to do now is on your sheet it should say mass of beaker plus the pencil. And so what I have here is just a standard pencil. And so what I have you do, I'm going to put the pencil in the beaker, and you can see that the mass increased. So you should have wrote down that number in the 90s of the empty beaker. If you need it again, rewind it. And now you have the mass of the beaker plus pencil. Now on your lab sheet, you need to find out just the mass of the pencil. So what you need to do, you need to write this number down right here. So it's 102.35 on your lab sheet. And then to find the mass of the pencil, you need to take the total mass, so this 102.35 number, and subtract it from your total your mass of your empty beaker. So again, it's this number minus the mass of your empty beaker. Go ahead, write that down. Once you've written that down, you can turn in the lab. Again, the reason that we don't need to predict on this digital scale is the way the digital scale or digital device is set up. It is already making that prediction like we did, or that estimation like we did in the graduated cylinder or the Meterstick. All right, so I hope you enjoyed another fantastic episode of Science with Surbeck.